Hello everyone, this is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about problems on high calorific value and lower calorific value of fuel. So before that, before we'll discuss problems, based on that calorific value, what are the formulas we are using, so what is calorific value, we'll discuss briefly. So first we discuss what is the meaning of combustion of fuels. So fuel is a combustible substance. During burning process, in the presence of oxygen, it produces heat. So that heat energy is used for domestic as well as industrial purpose. Already we know that. We discussed previous classes also, detailed discussion. So today's session will discuss briefly what are the formulas used for numerical purpose. So what is the definitions of that combustion and lower calorific value or higher calorific value? Just definitions we'll discuss. So now that combustion is a process burning of fuel. So fuel burning in the presence of oxygen, it produces heat energy. Is called combustion of fuel. So here, so in this given that combustion is a process of rapid exothermic oxidation. Rapid exothermic oxidation. So in which fuel burns in the presence of oxygen with the evolution of heat and light. With the evolution of heat and light. It is called combustion of fuels. So during burning process, fuel reacts with oxygen and produces combustion products and heat energy. So this process is called combustion or combustion of fuels. So now let's discuss what is the definition of calorific value. So generally this calorific value means how much amount of heat liberated. How much amount of heat liberated when a unit mass of fuel is burning is called calorific value. Here unit means 1 part, 1 kilogram, 1 gram, 1 unit. Okay, so how much amount of heat released or liberated when a unit mass of fuel is burning completely is called calorific value of fuel. So mainly the efficiency of fuel, it can be understood by its calorific value. So good fuel always contains high calorific value. Good fuel always contains high calorific value. The main constituent of fuel is carbon. If the carbon percentage increases in the fuel, it increases the calorific value. So calorific value increases means it acts as a good fuel. Most useful for industrial or metallurgical purpose. So the efficiency of fuel, it can be understood by its calorific value. So how much amount of heat liberated when a unit mass of fuel is completely burned. That is called calorific value of fuel. So there are two types of calorific value. High calorific value and low calorific value. So what is the meaning of high calorific value or gross calorific value? So high calorific value means it is defined as the amount of heat evolved when 1 unit mass. Amount of heat evolved when 1 unit mass or volume of the fuel is completely burned, and combustible products are cooled at room temperature. So that means, for example, if in case 1 kg of fuel be burning, for example, 1 unit mass of fuel is burning. In this case, how much amount of heat liberated? So that it we considered, and also combustion products cooled at room temperature. So for example, hydrogen present in fuel. So during combustion process, hydrogen reacts with oxygen and produces steam. So this steam is cooled at that means combustion product cooled at room temperature. That means steam condensed into water. Steam condensed into water. In this case, it evolved latent heat. So that heat also we considered here. So how can we determine the HCV of the fuel? How much amount of heat liberated when a unit mass of fuel is completely burned. So that heat also we considered, and combustion products cooled at room temperature. So that heat also we considered. And what is the meaning of lower calorific value or no net calorific value? So it is defined as amount of heat amount of heat evolved when 1 unit mass or volume of the fuel is completely burned and combustible products are permitted to escape. So therefore, net calorific value is always lower than gross calorific value, because here net calorific value we can consider only how much amount of heat liberated when a unit mass of fuel is burned. We cannot consider latent heat or combustion products cooled at room temperature. So that's why always a lower calorific value or net calorific value is lower than high calorific value. So how can we calculate this NCV? So LCV or NCV it's equal HCV minus latent heat of vaporization of water or products are formed. So in this case only we consider how much amount of heat liberated. Only that heat only we consider. We cannot consider when the combustion product cooled at room temperature. So that's why always lower calorific value or net calorific value is lower than high calorific value, because in high calorific value we consider both. That means how much amount of heat liberated when a 1 unit mass of fuel is burning, and also combustion products cooled at room temperature. That it also we can consider. That's why this high calorific value or gross calorific value is higher than net calorific value. Important formulas used for the determination of high calorific value and low calorific value for numerical purpose. Most important these formulas. So theoretical calculation of calorific value of the fuel according to Dulong's formula. So Dulong's formula for theoretical calculation of high calorific value or lower calorific value of fuel is, so gross calorific value or high calorific value it's equal 1 by 100 into 8080 carbon plus 34,500 H minus O by 8 plus 2240 sulfur to kilocalorie per kg or calorie per gram. So here 8,080, 34,500 and 2,240 is an assumption that 1 kg of fuel burning. If in case, in this case, the calorific value of carbon is the 8,080 and hydrogen calorific value is 34,500 and sulfur calorific value is 2,240. Just we assume that. So net calorific value is, how can we calculate this net calorific value according to Dulong's formula? So NCV equal HCV minus 9 by 100 H into 587. Here we considered only net calorific value. That means exact how much amount of heat liberated when 1 unit or 1 kg of fuel is burning. So that's why we can remove that latent heat or HCV minus 9 by 100 into H. Here H is the percentage of hydrogen present in fuel. And 587 is the, previously already we discussed, 587 is latent heat evolved. So NCV is equal HCV minus 9 by 100 H into 587 kilocalorie per kg. So these two formulas most important for calculation of theoretical calculation of high calorific value and lower calorific value of fuel. Now we'll discuss few problems based on that LCV and NCV of fuels. So how can we calculate the lower calorific value and high calorific value or gross calorific value of fuels? Now let's discuss few problems. So based on that LCV and NCV. So first one is calculate the gross and net calorific values of a fuel. calculate the gross and net calorific value of a fuel having following composition. So what is that? 82% of carbon, 8% of hydrogen, and 5% of oxygen, 2.5% of sulfur, and 1.4% of nitrogen, and 2.1% of ash. So given in this data, how much percentage of these elements present in given fuel. So now you can calculate the gross calorific value of fuel. So according to Dulong's formula, or Dulong's formula for theoretical calculation of gross calorific value of fuel is GCV equals 1 by 100 into 8080 carbon plus 34,500 H minus O by 8 plus 2240 sulfur calorie per gram. So already we know that this we assumption that the calorific value of carbon, hydrogen, sulfur calorific values are 8080, 34,500 and 2240. Already we know that. So here, what is the meaning of this carbon, say element symbol H, O and S? So these elements indicates that how much percentage of these elements present in given fuel. How much percentage of these elements present in given fuel. So here already it's given in this data. So we can substitute in this formula. So here carbon percentage is 82 and hydrogen percentage according to data it is 8% and oxygen is 5 and sulfur percentage is 2.5. So we can substitute all the values in this formula, and also it's present in this fuel is given in this data nitrogen and ash also, but we cannot consider because these are not increases the calorific value. That means it reduces the calorific value of fuel. If in case nitrogen present in fuel, it doesn't containing any calorific value. That's why it is undesirable. The same way, if in case fuel containing ash also, it reduces the calorific value. That means it do not supports the burning process. So that's why it is also undesirable. We cannot take this. It is negligible. Simply we say so. So we can substitute the only carbon, hydrogen, oxygen, sulfur percentage, whatever given in this data. So all these are substituted in this above formula. So after calculation, finally we will get gross calorific value of given fuel is 9225.97 calorie per gram. 9225.97 calorie per gram. And net calorific value of fuel is, how can we calculate this net calorific value of given fuel? So its formula according to Dulong's formula for theoretical calculation of net calorific value of fuel is NCV equal GCV minus 9 by 100 H into 587. This is the basic formula. So here GCV value is just now we calculated already here 9225.97 minus 9 into hydrogen percentage present in this fuel is 8. So we can substitute in this formula hydrogen percentage present in fuel is 8. So here we substituted here by 100 into 587. So what is the meaning of 587? Already we discussed in previous problems also. 587 is the latent heat evolved. So its value is 587 kilo per calorie per kg or calorie per gram. So we can substitute hydrogen percentage in this formula. Finally, we'll get 8,803.3 calorie per gram. And next one is calculate the gross and net calorific values of coal sample having the following compositions is carbon equal 80, hydrogen equal 7, oxygen equal 3 and sulfur equal 3.5 and nitrogen equal 2.5 and ash equal 4.4 percentage is present in this given fuel. So now you can calculate the high calorific value and low calorific value of fuel by using Dulong's formula for GCV and LCV. So what is the Dulong's formula for gas calorific value of fuel? It's equal 1 by 100 into 8080 in percentage of carbon plus 34,500 H minus O by 8 plus 2,240 sulfur. Here already we know that these are the assumption of can assumption 1 kg of fuel burning. During that we can assume that calorific value of carbon, hydrogen, sulfur, and these elements, the percentage of carbon, percentage of hydrogen, percentage of oxygen, and percentage of sulfur indicates that how much percentage of these elements present in given fuel. Present in fuel given in this data already here. So we can substitute the percentage of these elements like carbon, hydrogen, oxygen, sulfur percentage according to date from the data. We can substitute it in this formula. So then we'll get 1 is equal 1 by 100 into 8080 into percentage of carbon is 80. So we can substitute here percentage of carbon is 80 plus 34,500 into 7 is the percentage of hydrogen given fuel present in given fuel minus 3 is the percentage of oxygen present in given fuel from the data by 8 plus 2240 into percentage of sulfur is the 3.5. Percentage of sulfur is a 3.5. So we can substitute in this 3.5. So after multiplication, calculation, addition, after that finally you'll get gas calorific value of given fuel is 8,828.0 kilocalorie per kg. Gas calorific value of fuel is 8,828 kilocalorie per kg or kilogram. Now we can calculate the net calorific value of given fuel. So according to Dulong's formula. So what is the Dulong's formula for net calorific value of fuel? So NCV equal GCV minus 0.09 H or 9 by 100 into H, both are same only. So 0.09 H into 587 kilocalorie per gram. Kilocalorie per gram. Here. So for example, in previous problems we are using this one 9 by 100 into H. So it's equal, we can write here 0.09 H, that is both are same only. Okay. So here 587 is the latent heat of vaporized water. That means latent heat value, it's a fixed value 587. And H is the percentage of hydrogen present in fuel. So here how much percentage of hydrogen present in fuel? 7. So we can substitute the gas calorific value and hydrogen percentage present in fuel. So we can substitute these two values in this formula. Finally, we'll get net calorific value of the fuel. So it's equal, GCV value is 8,828 minus 0.09 into percentage of hydrogen present in fuel is 7. So we can substitute here 7 into 587 is the latent heat of vaporized water form. So its value is 587 kilocalorie per kilogram. So after calculation, finally you'll get net calorific value of the fuel is 8,458.2 kilocalorie per kg. Kilocalorie per kg. So in this way, you can calculate the lower calorific value and gross calorific value of fuel by using Dulong's formula. One more problem we'll discuss now. A sample of coal contains the following composition. So here carbon is the 84%, hydrogen is the 12%, and oxygen is the 2%, and sulfur is the 1%. So and the remaining being ash, remaining percentage ash. So if in case ash present in fuel, you can negligible because it doesn't supports the burning, doesn't containing any calorific value. So it is undesirable, cannot considered. So now calculate the gas and net calorific value of the fuel. So gas calorific value is equal 1 by 100 into, what is the formula? used for this determination of or calculation of gas calorific value of given fuel. So what is the formula? GCV equal 1 by 100 into 8080 carbon plus 34,500 hydrogen minus O by H plus 2240 sulfur calorie per gram. So here carbon, hydrogen, oxygen, sulfur percentage given in this data, already given in that data. So we can substitute that percentage of carbon, hydrogen, oxygen, sulfur in this above formula. So I'll get 1 by 100 into 8080 into carbon percentage is 84 plus 34,500 and hydrogen percentage is 12 minus oxygen percentage is 2 by 8 plus 2240 sulfur percentage is 1 calorie per gram. So after calculation, after multiplication, I'll get 1 by 100 into 6,78,720 plus 4,05,375 plus 2,240 calorie per gram. Calorie per gram. So after addition, we'll get 1 by 100 into 1 by 100 into 10,86,335 calorie per gram. So finally, we'll get gas calorific value of given fuel is 10,863.35 calorie per gram. Gas calorific value of given fuel is 10,863.35 calorie per gram. Now you can calculate the net calorific value of given fuel by using this gas calorific value. So what is the formula of determination of NCV of fuel? So NCV equal GCV minus 9 by 100 H into 587. So here we can substitute GCV value. What is that? 10,863.35. 10,863.35 minus 9 into here H. H means percentage of hydrogen present in fuel. So how much percentage of hydrogen present in fuel? 12. So we can substitute in this formula percentage of hydrogen in this fuel is 12 by 100 into 587. This is the latent heat. Already discussed previously. This is the latent heat 587. So after substitution, then we'll get is equal 10,863.35 minus 633.96. So it's equal net calorific value of fuel is 10,229.39 calorie per gram. So all these cases we observe that net calorific value is lower than high calorific value, because in high calorific value we considered how much amount of heat liberated when a unit mass of fuel is burning, and also we considered combustion product cooled at room temperature. So that's why this value is higher than net calorific value. But in net calorific value, we considered only how much amount of heat liberated when 1 unit mass of fuel is burning. Only that heat energy we considered. We cannot consider latent heat. That means combustion products cooled at room temperature. We cannot consider that one. Only exact amount of heat liberated we considered. So that's why that formula is the NCV equal GCV minus 9 by 100 H into 587 kilocalories per kilogram. One more problem. So a sample of coal contains, so carbon is 60%, hydrogen is 6%, and oxygen is 33%, and sulfur is 0.5%, and nitrogen is 0.2%, and ash is the 0.3%. So calculate the high calorific value and net calorific value of fuel. So what are the problem formulas we are using for the determination of high calorific values and net calorific value of fuels? So according to Dulong's formula, so high calorific value of fuel we can calculate it. What is the formula? HCV equal 1 by 100 into 8,080 carbon plus 34,500 H minus O by 8 plus 2,240 sulfur calorie per gram. So in this we can substitute the percentage of carbon, hydrogen, oxygen, sulfur. Percentage is already given in this data. So from the data we can substitute all the percentage of these elements in this above formula. So after substitution we'll get 1 by 100 into 8080 into 60 is the percentage of carbon present in fuel, plus 34,500 into 6. 6 is the percentage of hydrogen present in fuel, minus 33. Oxygen percentage is 33 by 8 plus 2,240 into here 0.5 is the percentage of sulfur in fuel. And here nitrogen also present, but it is undesirable because it is not containing any calorific value. So it is undesirable. So we can substitute all the carbon, hydrogen, oxygen, sulfur percentage in this above formula. So after multiplication, we'll get 1 by 100 into 4,84,800 plus 64,687.5 plus 1,120. So after the addition, we'll get 1 by 100 into 5,50,607.5 calorie per gram. So after calculation, finally get high calorific value of given fuel is 5,506.07 calorie per gram. This is the high calorific value of fuel, given fuel. Now we'll calculate the lower calorific value of fuel. So LCV equal HCV minus 9 by 100 H into 587. Here already we know that 587 is the latent heat value, latent heat of vaporization of water formed. So that heat is value is 587, and here H is the percentage of hydrogen present in fuel. So HCV is the high calorific value of the fuel is here 5,506.07. Just now we calculated. So we can substitute it. High calorific value of fuel is in this formula 5,506.07 minus 9 into here 6 is the percentage of hydrogen. You see, percentage of hydrogen present in fuel is 6 by 100 into latent heat is 587. So after multiplication, we will get that value is 5,506.07 minus 316.98. So after subtraction, we will get finally lower calorific value of fuel is 5,189.095 calorie per gram. So last one we discussed based on the HCV and NCV. So what is that? To calculate the gross and net calorific value of whole sample having the following composition. So your carbon is the 78, hydrogen is the 8%, and oxygen is the 4%, and sulfur is 4, nitrogen 2, and ash is the 4. So already we know that what are the formulas used for the determination of high calorific value and lower calorific value. So Dulong's formula for theoretical calculation of fuel of gross calorific value. So Dulong's formula for gross calorific value of fuel is 1 by 100 into 8080 carbon plus 34,500 H minus O by 8 plus 2,240 sulfur. So here we can substitute the carbon, hydrogen, sulfur, oxygen percentage whatever given in this data. So these elements percentage is how much percentage present in this given fuel. So we can substitute it in this formula. So after that we can get 1 by 100 into 8080 into 78 means the percentage of carbon in this fuel 78 plus 34,500 into H, hydrogen percentage is 8. So we can substitute here 8 minus oxygen percentage is 4. So we can substitute here 4 by 8 plus 2,240 sulfur. Sulfur percentage is 4. So here 4% of sulfur we can substitute here. And also it is present nitrogen ash, but we cannot consider because these doesn't have any calorific value. It do not support the burning. That means it reduces the calorific value of fuel. So we cannot consider these two are, if in case present in fuel, these are undesirable. Okay, so after that, after multiplication, we'll get that value is GCV is equal 1 by 100 into 6,30,240 plus 2,58,750 plus 5,600 calorie per gram. So after addition, after calculation, finally we'll get gas calorific value of given fuel is 8,945.9 calorie per gram. 8,945.9 calorie per gram. So next we'll calculate the net calorific value of fuel. So NCV equal GCV minus 9 by 100 H into 587 or 0.09 H into 587. So here 587 is the latent heat of water, and that means latent heat value is 587, and hydrogen is the percentage of hydrogen present in given fuel. So in this formula, we can substitute the gas calorific value and hydrogen percentage present in fuel. So gas calorific value of given fuel is 8,945.9 minus 9 by 100 into percentage of hydrogen is 8. So we can substitute here 8 into 587 is equal 8,523.26 calorie per gram. Lower calorific value of given fuel is 8,523.26 calorie per gram. So in this session, we'll learn about what is high calorific value, what is low calorific value, what are the formulas, main formulas used for the determination of high calorific value and lower calorific value of fuel. So always understood that lower calorific value or net calorific value is lower than gas calorific value, because net calorific value in this we considered only how much amount of heat liberated, exact amount of heat liberated when a unit mass of fuel is burning. So that's why always net calorific value is lower than high calorific value. So I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.